Hello and welcome to another math video. We're going to talk today about the sine rule and its proof. Proof-wise, just a note on the proof, you are required to see it. You may be required to recite it and use it again. It's pretty unlikely that you will be, though. In terms of where we're at, sine rule, we're going to do the cosine rule as well, which probably isn't a massive surprise to you given this is the sine rule. There's no tan rule. But this is our first real step into non-right angled tree. So you should have watched the video on labeling non-right angled triangles. This is the first rule to do with calculating sides, calculating lengths of non-right angled triangles. So right angled triangles, we've got SOHCAHTOA, we've got Pythagoras, angle sum. Non-right angled triangles, we have sine rule, we have cosine rule, we've got a few other bits and pieces as well. Without further ado, the sine rule. What the sine rule says, quite simply, there's two versions of it. Sine rule says that sine A on A equals sine B on B equals sine C on C. Okay, so that's the first version of the sine rule. There's a second version, and the second version of my sine rule says A on sine A equals B on sine B equals C on sine C. And these bad boys here, one of them is given to me on the formula sheet, the other one is not. I don't know which one isn't off the top of my head. You can get one from the other by just flipping all the fractions. So if you take sine A on A, flip it, that will make A on sine A, just A on sine A. Same here, flip that, all good. In terms of using it, why is there two versions of it? Well, generally this first version here is best for finding angles, given that we've got angles on top of our fractions. So A is the angle, B is the angle, C is an angle here, because they're capitals. If you haven't gone back and watched the labeling one, go back and watch the labeling video. It makes it nice and clear. Capitals are angles. So angles on top makes it easier to find angles. The second version, this one here, as you probably suspect, is good for finding sides. Okay. In terms of setting up our sine rule, what it looks like, if I draw a non-right angled triangle here, though it does look fairly right angled, if I give you two angles, so let's say this angle here is 30 degrees, let's say this one here is 70 degrees, and I have sides, so this side here can be x, this side here can be 10. In terms of applying the sine rule, this one here, you should be going, okay, well I'm trying to find the unknown side here, so we're going to be using this bottom version of the rule here. Labeling, if I label that little a, that would be big A, and if I label this little b, that would be big B. Okay, opposites, again, from your labeling video, opposites are all good. In case I haven't mentioned already, we only use two parts of the sine rule at a time, so I'm not actually going to use C here. And if I was to draw C on, I get C here and little c here. There's no relevant information on either the angle or the side, so C, not interested. Thank you very much. It was nice to know you. Setting up in terms of answering questions, what's significant here? A and sine A and A are opposites. Okay, so you should always get this opposite property happening on your sine rule. You've got one pair of opposites here. You'll also get yourself a second pair of opposites with B and B here. So you'll get another pair of opposites in there as well. The sine rule, you were looking for two pairs of opposites. Opposites, 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 opposites. And it's two sides, A and B, two angles, big A, big B. Two sides, two angles, sine rule. Okay, two sides, two angles, sine rule. And you might do a little bit of massaging, but generally two sides, two angles, and get them matching in opposites. Okay, if I really needed to use C here, I could be a little bit tricky and say, well, hang on, they make 100, so this would be 80, my angle sum of a triangle. So make sure I get that. Two sides, two angles, sine rule every single time. Massage around. Setting up for actually using the sine rule, like I've said, I know I've talked about this for a few minutes already. I'm going for A and A here. So I'm going to go, my side version, it's going to be X on sine A, on sine 30 here, equals, and in terms of the other one I've got B and sine B. B's on top here, little b's on top, so it's 10 on sine 70. So when you set your first line up, you should get the sines together. In this case, sines together on the bottom. Okay. If you're going to go solve that, multiply both sides by sine 30, because sine 30 is just a number. So we would get x equals 10 sine 30 on sine 70. Whatever that is. Okay. That's how you would do a question. I might come back and do questions in a different video, really focus on those because there are some interesting questions with sine rule. I want to show you its proof. So, take home points so far, 2 versions of the rules, make sure you've got them down pat, make sure you can find them on your formula sheet, make sure you can kind of massage around a little bit. Also, in terms of setup, looking for those opposite pairs. Always those opposite pairs will generate sine rule results for you. The proof. I said I want to show you the proof, and I'm going to do that for you now. So what we're going to do, we're going to start off with a non-right angled triangle. I'm going to label everything like I normally would. I'm going to call not that B. I'm going to call this B. I'm going to call this here C. Okay, so sides, little a, little b, and little c. And my proof, first I'm going to construct an altitude. An altitude through C, through big C, and we're going to call it H. Okay, so what I'm doing, I'm building a line through here, and that line I'm calling H. Because an altitude means it meets at 90 degrees. So that means basically it's the height of the triangle. So how high the triangle is, that's why I've called it H here today. In doing this, I've basically split my triangle into 2 smaller triangles. I've got a triangle here, the green triangle, and on this second side, I've got the pink triangle with this reddy, pinky color. So looking at the green triangle, in the green triangle, I'm going to take sine A, because we're going for sine rule here, it's got a bunch of sines in it. Sine A, and sine A, I've got this angle here. Sine's opposite on hypotenuse, because it's right angled. You can use right angled trig. So it's right angled trig, sine A opposite on hypotenuse, H on B. H on B. In my other triangle, I'm going to do sine B. Sine B, again, opposite over hypotenuse. Opposite here is H. I know it's confusing because you like H as hypotenuse, but the opposite here is H for the height of the triangle. And that's sine B, opposite on hypotenuse. Hypotenuse is A. Working a little bit of algebra magic, multiplying both sides by B here and both sides by A here. I'm going to get that B sine A equals H, and I'm going to get that A sine B equals H. So these now both equal to H. So my next line of working, I'm going to say B sine A equals H equals A sine B. It's an A. No, it looks like a bit of a C. I'm going to cancel that out. I'm just going to ignore that for the next little bit. So in this statement, I do have that B sine A equals A sine B. And I'm going to divide both sides by AB. Doing that, I get cancellation, B there, A here, A here. So I get sine A on A equals sine B on B, which is my sine rule proved. I know it's only 2 parts, but I can go through again, rearrange some letters, and get sine C hanging out as well. If you want a challenge, maybe go and have a go at doing that yourself. That's the proof. So it is a video. You can go back and pause it and go through the steps again. You can comment, ask me questions, or email, ask me questions, whichever one kind of suits. But that is the proof of the sine rule. Okay. You are required to have seen it. It's not too bad in proving terms. The next few rules that we do will be a little bit nastier, especially the cosine rule proof, but that's the sine rule proof. You need to know what's really the most practical thing. Learn the rules, and you can flip them upside down, learn the setup. So identifying where to use the rule, the opposite pairs is where to use the rule. Okay, 2 sides, 2 angles. Stay tuned, I'll put the example video up soon as well. It's also pretty meaty. Yeah, I mean, it's probably harder than the cosine rule, really. Proof of cosine rule is harder, but it's good to know it's part of the syllabus, and yeah, it's practical on a calculating sides and angles perspective. Thanks for watching, and I'll see you guys later.